Hello, my name is Mike Lemon. I am a corporate trainer for Tommy's Express franchise. We're here at our corporate site in Granville, Michigan today. We're going to be talking about the chemical pod, our chemical delivery system. The beauty of the building for operations is that I have full line of sight for anything chemistry-wise that I'm working on. I can adjust in real time and see the results. In a traditional car wash building with a back room, I'd be running into the back room to make my adjustments and then running back out to see the changes that I've made. But with the Tommy building, we can do everything full line of sight in real time. I can take my iPad with me anywhere in the building and have full control of all my equipment. For instance, right now, I just manually turned on our fire and ice at the beginning of the wash, our red hot lava. And then I can make any adjustments that I need to on my dilution ratios, on the air going to the foam generators. Today we're going to talk a little bit about the process, the components that are involved and how it works. So here we are at our chemical pod. I have full access to all of the components. The number one item that I want to talk about is our master air regulator. We're using pneumatic solenoid valves to turn outputs off and on. So it's very important, it's on our hourly walkthrough list as well, to check the air pressure on your master air regulator, anywhere from 80 to 100 pounds. You can see all of our different detergents lined up here. We have our pre-soap 360C, our Tommy Bright, which is our cloth soap, and all the rest of our products. All of these lines here are chemical draw lines. Let me show you a minute. A chemical draw line will go down into your detergent tote. We have a ceramic weight to hold it down into the product, and we have a foot valve at the very bottom. The foot valve is actually a check valve. So as we suck soap up, this foot valve will stop the soap from falling back down the line. This results in consistent chemistry delivery every time. On the bottom of the foot valve, there's also, you can take the cover off, and there is a screen. This is a maintenance item. If you ever have a problem with your chemistry not drawing properly, the first item to check would be the screen in the foot valve itself. So on your hourly walkthrough list, as we talked about, chemical draw lines are another item that we look at. We're looking at when the output turns off, is the soap falling back in the tube? You can see we have two lines here today that feed water to our chemical pod. We have a pump in the back room, the Grundfos pump. It's feeding the water here at a pressure of 200 pounds per square inch. And we're operating at about 115 degree water here. The water feeds a bank of components on the other side. We'll look at that in a moment. Here, the air goes into these different banks of solenoid valves. You can see our yellow Turk block here coming with a patch cord attaches to that solenoid valve. Here is the solenoid valve. This is a coil on that solenoid valve. When our PLC, which is commanding the outputs on in the car wash, turning on different soap functions, sends a message, we energize this coil. That acts like an electromagnet so that it pulls the plunger out, allows air to pass through the solenoid valve. You might want to think it simply as turning a faucet off and then on again. That air will then shoot out of the solenoid valve to the other side, where it's going to open up an air-actuated valve body. It also goes up to an air regulator. So if we're going to foam that product onto the vehicle, we'll have an air line going to the air regulator, where we can adjust what the foam looks like on the vehicle's car. Let's go to the other side. So now we're on the other side of our chemical pod. You can see we have our water feed coming in here. We always want to make sure we're maintaining 200 pounds of pressure on our gauge. This leads to consistent chemistry delivery. So our water feed is here, and it goes through our Hydroflex injectors. This is an air-actuated valve body. On the bottom of the valve body, we have an injector. You can see the different colors. The different colors represent different gallons per minute. The blue one in my hand is a 2.3 gallon a minute injector. We determine the dilution ratio of our detergents going onto the car by using gallons per minute and then different metering tips. This is our metering tip kit. Here's a light blue metering tip, very, very small orifice. This will thread into the injector, and then we will hook our chemical draw line, and that is where the soap is sucked through. So when we open and send air to an air-actuated valve body, that air will open this valve, allow our water to go through, and as the water travels down, it creates suction, which sucks our detergent up through the injector. They combine, and they go out through our ladder rack system out to the car. So we can simulate here. Devin is going to turn on this solenoid valve, and we can see how much air is coming through this line. So I'll plug that back in. So that burst of air will hold that valve open. So we have a chart on our maintenance pod which will show us how we measure a dilution ratio. Come with me a minute. So how we use our chart here, I have a blue injector with a light blue metering tip. So I go to my blue injector, 2.3 gallon a minute column, and I go and I look for my light blue metering tip. And I run my finger over here. I'm at 1 part chemistry to 66 parts water. When we come on site, our chemical specialist will set your tunnel up to produce the very best wash quality coming out. It's our job. There can be at times the orifice is so small that we may not be sucking proper amount of soap. So we're going to also train you on how to do a volumetric, so that you have the gauge at which to tell if you're delivering the proper amount of soap on each and every car.